Hi students, in this video we're going to look at how to use tree diagrams to represent the events and experiments done to calculate probability. So after watching this video you should be able to construct a tree diagram to display the sample space of multi-step experiments. You can then use your tree diagram to calculate the probability of an event, of an outcome occurring, and then with that table as a whole calculate probabilities of different outcomes or different events happening. Alright, so the things you have to recall from previous lessons are the formulas for calculating probability, and also tree diagrams use a bit of conditional probability as well. Now a key thing to note here is if you've got the probability of A happening given B, that equals the probability of our intersection of B and A over our probability of B. Remember this vertical line acts like a fraction, so probability of B is on the bottom and the probability of the intersection is on top. And then that means the probability of B and A happening will be equal to the probability of B happening multiplied by the probability of A happening given B. That's just rearranging this formula here to get what's on the right here. That formula, that idea, we'll be using in our tree diagrams. Now, tree diagrams are useful graphic organizers that can be used to display the sample space and probability of outcomes for multi-step experiments. Now, in many ways, they're much more useful than tables because tree diagrams can be extended beyond 2 step events to 3, 4, even more, just by extending out our tree diagram further and further. Now, in a tree diagram, we usually write the probabilities on each branch to minimize the size of a tree. So, for example, let's say we're talking about this probability here. We might write the probability on each arm of our branch, and that will help us with our calculations. It also makes it a bit easier to draw when we're just drawing the outcomes and putting their probabilities on the arms. Now the probability on each branch is actually a conditional probability. So this one here, right, is actually conditional because it depends on what happened in the previous outcomes here. So for example, this probability here, that's the probability of getting an M with the second pick given the probability that you got an M with the first one. This probability here is the probability of getting an M with the second pick given we got an F with the first pick. So these branches are conditional on what has happened beforehand. All right, now the probability of an outcome then can be calculated by multiplying the probabilities on the branches that lead to our desired outcome. So for example, if we've got a half here and a half here, if we want the outcome of MM, then the probability is going to be the half we have along this branch times the half along this branch. And that was the conditional probability formula we saw back in our recall section. So working along our branches, multiplying those together, the probability of getting M and M is 1 in 4. We multiply those probabilities on our branches and as we follow them along, and that gives us our probability for that event happening. All right, so let's do an example here. We've got an executive committee that's made up of a president, a treasurer, and a secretary to be selected from a group of volunteers for a local soccer team. The committee is to be selected from 3 males and 5 females. So draw the probability tree listing the possible sample spaces for the executive committee. So let's say we've got this first pick is for our president, that second selection is for our treasurer, and then this third selection is for our secretary. Now, the sample spaces we can get, or our outcomes, right, we can just get by following our branches. So this branch up here is MMM. This second one is MMF, MFM, MFF, FMM, FMF, FFM, and FFF. So obviously M stands for the males, F stands for the females. Now we've got our outcomes listed here, but it's also worth putting our probabilities on the branches too. So we've got 8 people in our that we're picking from. So at the start we've got 3/8 that are male and 5/8 that are female. Now these branches are where we start now getting into our conditional probability. So if we've already picked a male to be the president, then there's 2 males left and 7 people to choose from for a male treasurer. For a female treasurer, there's still 7 people to choose from, and 5 of those remaining are female. Similarly for the secretary, if we've picked 2 males for the president and treasurer role, then there's only 1 male left out of 6 people to fill that secretary spot. And similarly, there's 5 out of 6 females left, or there's 5 females left and 6 people to choose from for that secretary spot. So as we continue working through those, we can fill out all the probability branches on this particular tree. And so we've got 3/7 there, 4/7 there, 2/6, 4/6, 3/6, and 3/6. Now we could simplify those. We won't do that for the time being, but that's something you can do to help make your calculations that much easier. What I'll probably do with these is simplify them as I do the calculations as I need them. All right, so there's our probability tree. We've got our outcomes listed on the end here, and we've got our probabilities on our branches that will help us do our calculations. All right, calculate the probability that the committee is not single-gendered. All right, so let's find our single-gendered ones. So we've got 3 males and 3 females. What we're going to do then is use the complement of that. So what we can say is the probability of not single-gendered is going to be the probability of 1 subtract the probability of having 3 males on the committee and subtract the probability of having 3 females on the committee. So that'll be 1 subtract. Now for our 3 males, that'll be 3/8 times 2/7 times 1/6. And then for our all-female committee, that'll be 5/8 times 4/7 times 3/6. And when we put that into our calculator, 0.8036 or 80.36%. So what that means is if we're randomly selecting this committee, there's an just over 80% chance that there's at least 1 male and 1 female on this particular committee. Right, so after watching this video, you should be able to construct tree diagrams to display the sample space of multi-step events, use that tree diagram to calculate probability of an outcome occurring, and then use those probabilities to, and the whole tree diagram as a whole, calculate probabilities using that particular tree diagram.